the linear correlation coefficient, I will lovingly refer to that as the LCC, because I'm lazy, and it's more fun to say that. But the linear correlation coefficient is used to kind of measure a relationship between variables. Now, I didn't say like used to predict things. We're just trying to see if one thing correlates with the other. Does it make sense to kind of put them together? Okay, so I gotta see how much room I gave myself for that. This is the problem when you plan these out in ahead. Okay, so here we go. The linear correlation coefficient is noted by R, which again you're like, that makes no sense. I get it. And it's found by taking, let me go back to that, by taking the square root of big R. And you've seen big R from Excel spreadsheets with linear models and trend lines, okay? Now, so when you take the square root of R, you are going to get a positive number, always, okay? So, and that should be R squared, because it's going to give you R squared on the Excel spreadsheet. Okay, so you're going to get a positive number always, because the square root is always positive, but you have to determine if it's positive or negative, and it's based off the slope. So if the slope is positive, your linear correlation coefficient is positive. If your slope is negative, then your linear correlation coefficient is negative. So you want to make sure you're paying attention to that. Okay? So, gosh darn it, positive correlation. Well, stuff's going to go up. So if you have a positive slope, you have a positive correlation. Negative correlation, if you have a negative slope, then you have a negative correlation. Sorry, that didn't mean to make that. Now, the big thing is that correlation does not imply causation, and that is huge. You need to remember that. So just because two things are correlated doesn't mean one causes the other. I might be able to map it out that eye color correlates with type of soda people drink, right? If I find the right data, I can show a correlation with that. That doesn't mean that having blue eyes causes you to drink Sprite. No, that has nothing to do with it. Just because there's a correlation between two variables does not mean that one causes the other to happen. There are too many other outside variables. So just be aware that correlation does not imply causation. All right, so let's look at this. Now, you can see a positive correlation, right? They go up, and the biggest correlation you can have. So R is going to go somewhere between 0 and 1. Okay, now with that being said, the closer you are to 1, the closer you are to being perfectly linear. You can see positive 1, negative 1, and that they are both perfectly linear. Your graphs line up. That means your data is perfectly correlated. Now that doesn't happen very often, right? So you can see here, we've got dots on both sides, that has a positive 0.5 and a negative 0.5. The closer you are to 1, the more linear, the more related your variables are, the more correlated, okay? In this middle one here where you have data all over the place and there is, right, that's an R equals 0, there's no correlation. So it's just important to check that out. So positive correlation goes between 0 and 1, negative correlation goes between negative 1 and 0, right? But you have to be within the 0 to 1 range, whether positive or negative. That's just how it is. Okay, so what is the linear correlation coefficient for the CPI over time? Well, R squared is 0.8796. So I'm going to take the square root of both of those, right? Because the square root of R squared gives me R, and so you type it in, square root of 0.8796 gives you 0.9379. And this is positive because look at your slope. Well, your slope is positive, it's got a positive number, and it's going up. So I have a positive linear correlation coefficient when it comes to CPI over time. Now, write a sentence explaining what this correlation means. So we could say, there is a strong, I say it's strong because 0.9379, we're getting close to 1 if you're in the 0.9. So that means it's a strong, positive, linear correlation between months after January of 2011 and CPI. Okay, so I tell you it's strong because of the value, right? 0.9 and above is strong. I could even say like super strong or very strong or extremely strong, but it's strong. It's strong, it's positive because it's going up, and it's a linear, right? It's showing that there is a linear correlation between, and then you're going to want to name your two variables. So, less than 0.9, you could say somewhat strong. I would say if you get down into the 0.5 and 0.6s, you're talking about a weak correlation. Anything less than 0.5, there is no correlation, right? That's just crap everywhere. Can we say there's cause and effect? No. And why not? Because correlation does not imply causation. Repeat that. Make that your mantra. That's important. And I believe that is the end of our OCC video. Enjoy!